Hello, everyone. Thank you very much for joining us. I have the pleasure today to have John Carnell with us, the author of Spring Microservices in Action. And we're going to learn a lot of nice things about both Spring and microservices today. Thank you very much, John, for accepting this discussion. Let's see what you can tell us about Spring Microservices, but also what about the book that you have written?
Yeah, I think the biggest lesson that I've kind of learned in microservices is that it's easy to write a microservice, but it's very difficult to operationalize it and to really understand all the kind of work that goes into it. So it's easy being a relative term, right? It's easy to build it all out, but then you have to worry about resiliency and scalability. And these are a lot of these things that you don't think about when you first start out. It's been an interesting journey because the company I currently work for is based completely on microservices, massive number of microservices. And the lessons that we went into building it versus how we came out of it were kind of evolved quite a bit over time.
The popular opinion is that if you create a Spring Boot service, expose some REST endpoints, and eventually connect to a database, you suddenly have a microservice. And in reality, I think that's not really like that. And you explain a lot about it in the book and a lot about the pitfalls, but also the other things that need to be attentive. Which are the most common things, aside for resiliency, which you have already mentioned? What other things are very important for someone to know before they jump into building a microservices architecture?
Yeah, I mean, there's a lot of surface area in that question, but I'll try to definitely answer it as best as I can. I think the number one thing is you've got to think about making your microservices stateless, which means what's the implication of that? It means that they have to be cookie cutter. So when you build a microservice, you have to make sure that your configuration is completely isolated from the deployment, that your deployments are immutable, that they could just be pushed out there. Those are the basics, right? Is just being able to say, hey, can I spin up multiple copies of my microservices at any given time? Because the reality is microservices go down all the time, right? I work at a cloud-based company. We have stuff go down, and the trick to resiliency is to be able to very quickly detect those outages and self-heal. And so that was what kind of originally attracted me to Spring Boot and Spring Cloud. Is I've spent the majority of my life being a Java developer. I can still remember the Dancing Dukes back when Java first came out. And I always liked Spring for a lot of the kind of wiring capabilities that it brought to it. But what really got me excited as I started working with Spring and Spring Microservices is the ease in which it kind of took care of the infrastructure and brought it all down to a single deployable binary that was kind of executable. That to me kind of blew my socks off because I had previously been EJBs, working in WebSphere, working in JBoss, working in all these things. And, there was so much complexity that got boiled down and abstracted away from me. The other thing I like to think about microservices is besides the basics of, hey, can I start up a microservice? Can I clone it? Can I pretty much just deploy it and make it immutable? Is really the scalability and resiliency. One of the earliest mistakes that we made when we were building out our services, we didn't give it a lot of thought. We didn't use something like Resilience for J or Hystrix when we built services. And people often say, "Oh, microservices are so great from breaking down a problem." But what a lot of the countervailing argument of that is that microservices actually make your environment more complex. Because now instead of one big monolithic app where you can kind of trace through all the source code, you've got hundreds of microservices with maybe another 4 or 5 instances each, and you have to be able to handle a failure in another part of your system or another part of your one of the microservices. Because if you don't, then you tend to have cascading effects. You get thundering herds, you get kind of like a cascading collapse of services. As one service fails, it starts taking down all these other services. So that's something I always tell people, that the microservices piece is easy. It's just writing the code. But you got to think about all those other things, and start from the beginning, because it's a real pain to have to go back after you've built all your services and now put resilience for J circuit breakers in place. It's very, very difficult to kind of reverse engineer that stuff, and it's long and boring, and nobody likes to do it. After some, if you start from that in the beginning, it's like you kind of start with that mindset, like every call I make in my service could fail, and how am I going to deal with it? How am I going to, be able to time out a circuit breaker, retry without human intervention? That's kind of the thing that is all in with Spring and Spring Cloud and all the capabilities it brings.
So in the past, when we started with the idea of microservices, they were sold as being a solution for everything. But now we know that's not necessarily this way. And I wanted to ask you, in your perspective, if I have a requirement of building a specific system on my plate, when should I decide that microservices is the choice, and why should I choose Spring for building my microservices?
Yeah, when I look at it, not every application is a microservice-based application, right? If you've got a small departmental level app that's just doing a single task, a microservice can be overkill, right? Or a set of microservices can be overkill. I'm actually reading a really interesting book now. I forgot the name of the author, but it's called The Topologies of Teams. And it gets a lot into like Conway's Law and how you have to model your business after your architecture rather than trying to fit your architecture into your business. And I think that's one of the things that I look at as a tipping point is the moment you have to start coordinating a lot with other groups and interacting with other groups, then you have to start asking yourself, how do I divide and have very clear boundaries between groups? Because there's a lot of things that come out of that, right? There's a flexibility of deployment, speed of deployment, right? Because you're not having to deploy this big ball of mud and have everybody do regression testing when you push things out. But to me, a lot of times microservices are about, when I have to start interacting across groups, they help me define very well-defined boundaries of functionality and also responsibility. Spring as a technical platform is great. In my mind, there's no benefit of building an overall microservices architecture and just saying we're going to do it all in Spring. My company's philosophy is like use the best tools for the job. And so some of our teams build microservices in Spring. Some of them build them in Golang. We've got a couple of Python microservices, a lot of Node.js. So it really depends. Once you start decomposing your problem space into microservices, it really kind of shrinks it. And then it allows teams to look at it specifically for the problem that they're trying to solve. It gives them more control. And in many cases, Spring is a great way because a great tool set and Spring Boot is great because it allows groups to leverage usually a lot of the skills that most organizations have. I mean, let's face it, there's so many Java developers now, and there's such a deep and wide pool of Java developers that you can take any one of them. They can get very quickly up to speed in Spring Boot and run with it. And then they layer on Spring Cloud. I think the other thing is I'm always like, don't chase the technology just because it's like, looks cool. I've seen so many organizations that they're like, oh, we're going to do Spring microservices, or we're going to do microservices, and we're going to do Docker, and we're going to containerize everything, and we're going to do Kubernetes, and we're going to do it all at once. And it's like, no, it takes time to institutionalize that knowledge within your groups. It takes time to learn from your mistakes. And I've seen so many projects just kind of fall on their face when people don't start incrementally and don't start kind of taking one step at a time. Let's just start learning, building some few simple services, Spring and Spring Boot, and kind of layering stuff on there.
In the end, and I think you already answered one of my next questions was about the microservices systems being polyglottic. So you said choose the right tool for the right job. That means Spring is excellent, and if it fits well, choose it. But otherwise, if Python is better for the job, then you should choose Python. That's correct. That's what I heard.
Yeah, and it's a lot of times bringing in, and I say this over about programming languages too, is you've got to choose a language that is best for the best tool for the job, but also the best tool for your organization. I've been guilty of, wow, this is a really cool programming language. We should build a service in it and try it out. And one of my stories I have is Clojure. I've used Clojure, love Clojure. It was great. A couple of the guys, my manager came to me and said, "Hey, we got this little service. Do you want to build it in Clojure?" And I'm like, "Yeah, this will be great. Let's." And we built it. It worked great. The problem is it was such a shift in mindset for the rest of the team that very few other people learned the language and learned how to support the service. So over time, it became more and more just myself supporting it. It was very difficult to hire programmers because the talent pool was much smaller. And so again, you've got to look at what's right for the problem at hand. And the problem at hand is not only the technology, but your organization's capacity to support that technology, that programming language.
Organizations, I've seen this approach of having some kind of a template. So I've heard managers trying to rather have a template for their microservice, and they choose a technology and they document the way you should build your microservice, and then they force the teams not to get out of that template. And the reason they do that, or at least the reason I've heard them doing that, is to keep things simpler and have easier onboarding of new fellows. But is this a right approach? Doesn't it have also some pitfalls? What's your perspective on this kind of approach?
I forgot. Sorry, just a moment. Somebody was calling me and it popped you off the screen. So the thing that I look at is it's really about the technology. Sorry, I lost my train of thought. Can you go ahead and repeat the question?
Yeah, sure. So in a lot of organizations, I've heard engineers or lead engineers trying to impose a template for the microservice. So they
okay.
template and then they force the team go into that template. And what's your opinion on doing this?
I always call it, you got to be careful because that's a seduction of standardization, and standardization can be good in many instances, right? But I think it really comes down to the problem space. There's a couple of things that I have. I think the idea of templates work well if your entire team is already working in a particular technology set. You've got a lot of churn in your development team, so you're constantly bringing on new people and onboarding new people. The downside to templates is that they don't really cause people to think, and it might not be the right problem. And I can't tell you, I see this all the time. My favorite template is when people try to standardize with CloudFormation or like some of the tools like Ansible and stuff like that. When you start getting a large group of people, they start just cutting and pasting without understanding the context of how they're working. And so as a result, they are like, well, I just cut and paste this. And I'm like, well, why did you open up these ports? Oh, well, that was just there. That's what the template had. And so that's the other side of standardization, right? Is you don't have people understand the context of what you're doing. And I think sometimes it really oversimplifies the problem. I'm not against standards and I'm not against but they, like anything else, they can be taken to an extreme. And so, it kind of goes back to, I used to work in a company where it's like, all we'll ever do is Java. Everything has to be Java. And it's like, yeah, but I only need to write a little bit of Python code here for a one-time standalone application, that we're going to throw out later. Oh no, you have to write it in Java. But I think when we talk about standards, it's anything else, like anything else, context matters. You've got to look at your organization and you've got to look at, like, am I bringing people on? Where am I using the standards? Because very quickly you can run into people are just following it like a recipe, but the recipe might not be for what the thing you want to build. It's the same with design patterns, right? I used to work at a company where we had what I called the pattern happy architect. he had the Gang of Four book in one hand. He's like, we must do every one of these patterns. And so our code became so layered and over abstracted that in order to do anything, even make a small modification on a field, like add a new field to a model, it was like a week task just to go through and figure out and add all this stuff to the layer. So it's a little bit of a wishy-washy answer, but I always go standards. It depends. You got to kind of right size what you're doing to your organization and be willing to change it if those patterns aren't really introducing efficiency.
Think of it the microservices subject, but going back to Spring, because your book is on microservices with Spring. What do you like the most about Spring as a framework? What's the strongest point from your perspective on Spring?
Well, it's funny because Spring, I think Spring Boot in particular completely reduced the complexity of a standard Spring app. I was always, when I started with Spring, I worked with initially with the XML configuration. And when the first time I saw Spring Boot with annotations to annotate this stuff, it's like, wow, this is really, really simple. The other thing that then if I move into like Spring Cloud is they just solve a lot of problems that my organization, when we were very early microservice adopters and building our platform, there was a lot of stuff we built ourselves that later Spring Cloud built. And it's like, man, I wish we could have done that because that would have eliminated so much complexity in our code or would have eliminated so much time. Because the thing you got to remember, developers love to build frameworks. I'm an engineer. I love to build infrastructure. It's cool. It's intellectually satisfying. But then you have to build and maintain that over time, right? Then you have, and you got to ask yourself, is this core to what I'm trying to build? And in many cases, Spring builds a lot of this stuff for you. It kind of comes out of the box. And the Spring framework has such a wide adoption that you've got enough coverage and support that sooner or later, you're going to find something that somebody to help you with it or some kind of documentation out there. I've worked in many organizations where they built their own frameworks. I won't use the word that I called them, but it was the problem is that the one or two guys who built it, they'd move on, and then everybody else would be left with the consequences of that. So, yeah, that's why I like Spring, because it just kind of comes with everything already there.
In Spring Microservices in Action, you cover some other topics also beyond Spring and using Spring. You cover Docker, you cover security, resiliency, as you already said, which are some points that you consider very important for someone starting now learning about microservices that they should take into consideration up front, and they should not forget about them, regardless of the technology they choose. Yeah.
And that's, to me, a lot of that gets into how are you going to debug these things? How are you going to, I keep using the term operationalize them. Like one of the first things that was a big wake-up call for me is trying to debug across multiple microservices. So you want to start out very early thinking about how you're going to inject correlation IDs into your services. How are you going to log? How are you going to do log aggregation? Because when you got multiple services, and those services going to be ephemeral and die at any moment, and new ones could be brought up, you need the ability to be able to trace a transaction all the way across all the different services, and you need to have that aggregated. A lot of people don't think about that right off the bat. And so they build their services, and then all of a sudden it's like, oh, well, how are we going to debug these? How are we going to see what's going on? So that would be the one thing, is really kind of thinking about that. The other thing is really thinking about, like I said, resiliency. Make that a first-class citizen. Make sure that you think about every remote call you make is an opportunity for failure. Like one of the lessons we learned is we use caching quite a bit in our platform. And we're like, oh, caching is so great. If the database is unavailable, we can at least keep going and while the cache is going. But what happens when your cache, like your Redis cache, suddenly is having performance problems? right? And that just drags your functionality down. Well, you've got to be able to cut your circuit breaker on that quick. So those are things, and then anytime you bring in a technology, because again, Spring offers you everything, right? It's got all the connectors and hooks that you could possibly want. But you've got to think about, like, every time I bring in this new technology, how can I turn it off? Like, I bring up the Redis cache, right? How can I flush my caches in a microservices environment? That was a lesson we learned. We were very heavily into caches. And once we got into production, it's like, oh, I got a bad cache record out here. How do I get that? So you have to build operational stuff into your microservices. Think about tracing, think about resiliency, think about building endpoints for doing management of things, because you might not have access to the production environment itself. So that's what I would kind of think about and try to give people advice on when they start with Spring Microservices.
Other things that I've heard many people ask me on my YouTube channel is how and what is the best approach to test microservices architectures, sometimes even prior to releasing them and sometimes after releasing them. We've heard different approaches, like on Netflix, chaos engineering. Is there a silver bullet approach or something that we could use and it will work in any situation? Or which would be the approach that you would suggest someone who?
Yeah, testing is so critical, and it's like in many of the kind of older school organizations, you have a QA group who basically, they can be very talented people who really know the processes, platform, systems, but they basically are button pushers, right? They go into the app, they push the button, they kind of understand the business process. And I don't say that as a denigration. Some of the best people I've met are like really good or testers. But in a microservices environment, you've got to take a really layered approach to testing. We do unit tests and we do integration tests. So unit test, your standard JUnit. I'm going to make my testing a very small function method, completely independent with no dependencies on other classes. We also do a boatload of integration tests where we're mocking out end to end the remote calls so that you can actually test out the entire process. And it's funny because it takes oftentimes, and this is a frustration that a lot of developers kind of use to rationalize skipping tests, is it takes longer to write the integration test, sometimes a week longer to write the integration test than it does to actually write the code. But what you're really doing is you're kind of putting a deposit in the bank, right? For future changes, you make those changes, you now have at least some level of confidence of being able to go out and test your code, make sure that your code is working. The last layer is one that when you've got an individual microservices developer, you're not thinking about this, but when you're thinking about it in the ecosystem and you're thinking about your CI/CD pipeline, is automated smoke tests and acceptance tests all the way up through production, right? So every time you deploy, you're kicking off a whole suite of tests that check out the system and make sure the functionality works. And the thing is that oftentimes, if you have the luxury of having extra people and coders, make those people who are writing the acceptance tests be completely independent of the actual microservice writers, because one, they're going to attack it. Like we have a dedicated QA group that embeds people within our teams. And these guys are really good. I mean, the way they treat testing is their own discipline, but they're all engineers. They're all coders. And I can't tell you the number of times that one of our testing, our QA guys has saved my bacon because they know the platform end to end and they can write acceptance tests. And the thing is too, is you want to tie those acceptance tests every stage in your platform, including when you deploy to production. Because one of the things that we've been able to really respond quickly on is we have these basic smoke tests that are constantly running. And as soon as something deploys to production, if it fails, it pager duties out and somebody's being called, and then they can go and look and say, give me everything that just got deployed. And at least then you know it was a change. 9 times out of 10, it's a change that happened. But what I'll say about testing is it's a lot of work. And what I often tell people on my team is testing is only good as the assumptions you make in testing. So your tests aren't going to be bulletproof. The assumptions that you're making on how you're mocking something out, if you're wrong, your tests are going to be wrong and you're going to have bugs in production.
With today's agile approach, we are sometimes wrong from the very beginning, so our tests are wrong. So it can happen.
Yeah, exactly.
John, there is only one more topic I would like to hear your opinion about, and that's security. And how much does microservice architecture, choosing a microservice architecture, impact the security and the way we secure the system? And how and what does Spring offer to solve the issues and secure?
Yeah. Security is like one of my least favorite topics because it's hard, right? It's like, you're like, I don't quite get this. Why do I got to do this? I'm focused on this, but it's also the most important. So I often tell people, your security starts with coming up with an overall strategy of how your services are going to do. We use OAuth, right? And we use usually some kind of role-based check on all of our services. But what you don't want to have happen is have your individual microservices teams coming up with their own security. Spring has really, really good OAuth support. And I would encourage developers to really spend some time not only learning Spring, but really understanding OAuth and all the different OAuth flows. Because even now, like currently, I run a developer engagement team at my company. So I work a lot with third-party developers who maybe haven't done that much cloud development yet with microservices. And so many of them, the first thing they run into is security. Like, how do I authenticate? What's the difference between an implicit grant and a client credential grant? Why doesn't this work? And so I would encourage people, even when I wrote my book, I was really like not looking forward to writing the security chapter. And I'm so glad I did because it really, really is important. And, the other thing too is security, hand in hand with security is also understanding, I didn't cover this, but understanding rate limiting, right? Because everything you call is going to be rate limited. And you want to think about how everybody coming in is also how you want to protect your platform from abusive patterns through rate limiting, including your security. Because we just had a situation a couple of months ago where somebody was like, well, I used to be able to just create all the OAuth clients I want, not the tokens. And it was killing our service. Somebody had a bad piece of code. They were just scrolling through. They were rolling through and looping through. And just every time they were doing this, they would create a new client, even though they were only using the same token. It was just a bad piece of code. But we didn't think about rate limiting. And so as a result of that, we had to put rate limits in place. And, developers often don't think about like, hey, what happens if I get rate limited? How am I going to retry? So sorry, I took your security question a little bit into two different directions. But the main thing I would say is absolutely learn security, but don't let your individual microservices teams come up with their own schema for that. It's just too important. And this is one place where standards really will help save a lot of time. The other thing I would really recommend, and this has less to do with Spring, but everybody's run into it, is do vulnerability scanning. It's so easy and keep your dependencies up to date on your microservices. This is something that's kind of notorious, particularly among Spring and Java developers, is they don't keep their dependencies up to date. They don't upgrade their framework on a regular basis. And that's technical debt, And so you don't want to be caught in a situation like the Log4j injection attack, I think last year, where it's like, hey, I have to upgrade and I'm running a really old version of Spring. And so now all of a sudden I'm under the gun and I have to go and do all this work. And you didn't ask me the question what I like about or dislike about Spring, but it's like, oh, now Spring is throwing this vomiting all these exceptions at me, and the magic's gone because Spring's all fun until you get one of those exceptions that you're like, oh my God. So keep your dependencies up to date. That would be my advice.
Unfortunately, many organizations try to save money by saving the time of upgrading, which is wrong, but it happens. So, guys, if you are following us, like you see, it's many people, many smart people advise you to upgrade, so to upgrade your dependencies. John, thank you very much for these excellent discussions. Followers and friends, I will share with you a few vouchers for John's book, Spring Microservices in Action. But if you don't get to use one of those, I would still recommend you to get the book from Manning or from Amazon and read it, because it's an excellent piece of information that it makes everything relevant about using Spring. And not only if you use microservices, but even if you don't use microservices, the things you get from the book are still very relevant for everyone. Thank you very much again, John, and hope to discuss with you in for some other occasions as well.
Absolutely. Thanks for having me.